Okay. Good morning, everyone. Welcome to the first session of the Fundamentals of Digital System Design course. It's offered by the University of Moratuwa, Department of Electronics and Telecom Engineering. So we'll use the time today, approximately 1.5 hours. So we expect to be done by 12 noon Indian Standard Time, Sri Lankan Standard Time. So during that time, we hope to give you, this is our agenda. We hope to give you a brief breakdown mainly about what the course is going to be, what our thinking behind developing this course, and of course, a few perspectives from the industry. So we'll first start with basically giving you the motivation why we are doing these courses, and then we'll have a keynote, mainly an experience sharing sessions by one of our own, and then the industry perspective from one of the companies that partnered with us in this journey. And finally, we'll tell you about the course, what you will get to know throughout the 8 weeks or so, and a few logistical items as well. And then finally, you will be allowed time to ask any questions, get some feedback on that. Okay, so I hope the plan for today is clear. With that, let's move on to the first agenda item, that is about the chip design roadmap. So I'll take 10 to 15 minutes to tell you why we thought of developing courses in this area and why that matters, right? So when you look at the area of chip design, there's a lot that we can cover. And the people that we have here in this course, they have hands-on experience in this whole area. So I will be the course coordinator for you in this course. I'm a senior lecturer at University of Moratuwa Electronics and Telecom Department. Graduated from the same department and did my PhD in University of Florida, specializing in hardware security. Yeah, so a few others who are again from the same department will be joining us, and they are from different parts of the world, even right now. So they will be delivering the material for you. So we'll get to that. Before that, let's try to understand why we thought of developing these courses and where exactly are we headed. So maybe about 20, 30 years ago, like the late 1990s, the early 2000s, especially with players like Apple in the market and IBM, the personal computer started to become a thing. So it was no longer a luxury that a few selected companies had. It became a commodity. It became an appliance that we have in our day-to-day life. So when you first had these computers, you can run Microsoft Word, you can run some other application, you can play some games. That is the general nature of a computer. You can do a whole bunch of things, not just one thing. So in that setup, we generally refer to that as general purpose computing because it can serve more than one purpose. And now, from that computing paradigm, we are more and more shifting towards embedded systems. So these embedded systems, from the image, you can figure it out. The main difference is it is done for a particular application. For example, using a POS machine, like a point of sales machine, you cannot do word processing, right? So that's not possible. Using a digital camera, you cannot play a game. Well, maybe you can, but not the typical game that we refer to, right? So these are limitations of embedded systems. So when I say limitations, that sounds bad, but at the same time, when we have these specific hardware devices to do something, then that gives you one performance because it's optimized for one task. It consumes very less power compared to your PC at home. So there are benefits like that. Now, because our computing resources are getting mature, more and more people are going into embedded systems, IoT, application-specific devices. So this is a good thing in the sense that we are maturing in terms of technology. And when we have those capabilities, we can get things done really fast. So this shift is happening right now. It has happened for the last decade or even more. So in this setup, we want you to be the engineers that are capable of addressing this. So in summary, that is the whole motivation behind this. There's more information to that, so we'll get to it. So throughout this session, we wanted this to be interactive. So to get things going, today, what we will do is while we are speaking, we will ask you some questions and you have to give those answers through a platform called Mentimeter. Okay. So my kind request to you, those who are in a position to do it, please go to Mentimeter and let me share that screen. so that you can take part in this conversation actively, I'll give you a few minutes so that you can join Mentimeter without any issues. Okay, sorry. Here's the link. So if you can go here and join Menti, then we can have a conversation through this. By the way, when you join it, please don't log out, because we'll have 3 questions right now, and a few more questions will come in the near future. So stay connected. Then we'll have questions as we move forward for the next 1.5 hours. Just in case, I'll turn my video off to save bandwidth so that everybody can hear me without any issues. We'll give you a few seconds for you to join Mentimeter, and then we'll go into the questions. Let's see how many people have joined so far. Right, so we have 53 and counting. We have 100 plus in the call. So we'll give you a few more seconds to join. You go to this website and you put the code 12544882. Great. So I think we have 60 plus. That's a good number. So we'll see who the winner is. These are general knowledge questions, by the way. We don't expect you to have any information or knowledge about digital system design. You are here to learn them. So our objective is not to quiz you on that. Very basic questions, general knowledge, and also a few technical questions that will not be very hard. All right. Okay, so the winner, whoever that is, there's one pending gift that should go in one of our previous courses as well. We'll get to that, definitely. This winner, whoever gets the highest mark, you will get a small gift from us. So just to keep you motivated and engaged in the quiz. But anyway, it'll be fun. So I hope you are ready. We'll go to the first question. We have 80 plus people now ready and waiting for the question. So here it is. By the way, you get marks for the accuracy and also how fast you give the correct answer. But if you are very fast, but you give the wrong answer, that doesn't really matter. So make sure you take your time and get the answer correctly. But if you get it fast, you get more points. Right. So 10 questions. Here's the first one. Okay, so those who are not familiar with Menti, I hope you got a hang of it as a part of the first question. So most of you gave the right answer. The question was, what is the primary material used in the manufacturing of semiconductor chips? So many materials go into the picture, but it's mainly silicon. Right. Let's see what question number 2 is. Hope you are ready. Okay, we have many people giving the not so correct answer. So TSMC, which is a Taiwanese company, the question was the largest manufacturer of semiconductor chips, not the designer or the producer or anything like that, right? So you can Google this. TSMC happens to be the largest manufacturer of semiconductor chips. So not many people know this, and we expected this to be the case. But yeah, so whoever designs, like even if you take NVIDIA, for example, they do the designs and the manufacturing happens in other fabs. And TSMC is one example for that. Okay. Intel, of course, they have their own fabs. The throughput or the number of in terms of the revenue as well as being the largest manufacturer, it's TSMC. So we're coming to the last question in under this segment. We'll see what that is, and we'll go back to the slides. We'll talk about it a little bit more and then come back to the Mentimeter questions. Here we go. Okay, so for this one, most of you got the right answer. The question was which of the following is not an example of a company in the semiconductor value chain. Tesla is a consumer, but it's mainly an automobile company. Every other one here, NVIDIA, ARM, Broadcom, they either design or they manufacture or both. Right. Okay, so just to break the ice, a few questions, general knowledge. It's not surprised that most of you didn't get TSMC, and that's exactly a point that we wanted to make as well. So let's get to the slides and we'll move forward. So here are like a collage of companies, logos of companies that are in this space. So it's a huge market. It's $1 billion industry. And this market is in fact one of the main beneficiaries of the recent AI boom. I'll tell you why. So when you look at the history over the last, let's say 4 to 5 decades, there has been quite a few technological revolutions that we went through, and none is as fast as the AI revolution that we are going through right now. So we had the personal computers, we had mobile computing, we had the cloud computing paradigm coming in. But right now we are in the age of AI, and ChatGPT was kind of like the trigger point. And then so many other players came into the market, and these players operate at different levels. So what you see in this figure is how long it took the services to reach a certain amount of users, 1 million, if I'm not mistaken. So as you can see, for ChatGPT, it's in a league of its own. It's really fast. Within a few months, they hit the targets compared to, let's say, your favorite products, maybe Facebook or Netflix. It took them years. But ChatGPT, in this case, it's only a few months, right? So you can see how fast people are adopting these solutions. And for people to adopt these solutions, we need to enable this technology. And NVIDIA is one such enabler because they do hardware accelerated computing. They have their own, I mean, I'm pretty sure you know them as a GPU company, where you get a brand new desktop PC and you plug in a slot in an NVIDIA card, and then you can play fancy games with it, all the high-end graphics. But the same, not exactly the same technology, but a similar technology helped them train these machine learning models really fast, or deep learning models. So even if you take companies like OpenAI and even Tesla or X or any of that set of companies, you will see people buying NVIDIA cards, NVIDIA hardware accelerators in bulk. So you'll have like a whole bunch of GPU farms or H100s, and then they will be used to train the models. Why? Because if you use like a normal processor, like the usual processor that you have in your PC, that's going to take months or even years. But when you have hardware acceleration, that's going to do things really fast. And these are not cheap. In the picture, you see the NVIDIA earnings year over year, quarterly reported. And when the AI boom happened, you can see early 2024, you see the spike, and now we are coming to Q4 of 2024. So NVIDIA actually happens to be the real winner of the whole AI revolution because they just sold a whole bunch of hardware. And it's like huge profits for them. You can see the quarterly revenues of NVIDIA. So the point here is, when we talk about something like an AI revolution, it's not only one player, it's not only the players in the software space that will benefit from it, but there are a whole bunch of other people in this whole supply chain. When you develop software, that typically sits here at the top. You can see the product or the application, right? So this is where most of the software companies operate in. Some work at the programming language level, but mostly they just use a language that is already available. But when you look at this technology stack, you can see that a lot of things can be done at the lower layers. Because in the whole hype of AI, many people try to, let's say, use the GPT-4, and then you make some API calls to it, you get some things done, you build an application. That is not the only thing you can do. You can do a whole bunch of other things. And NVIDIA is one such example. Now, I'm not telling you that tomorrow you can go and build a company like NVIDIA. It's a huge capital investment. But there's a lot of other things that we can do even without a huge capital investment. So that is what we want to teach you. How do you get started in this area and then become an engineer with the skill set so that you can contribute to this value chain? So that is our objective, right? So in this course, you will mainly be dealing with the lower layers. You'll get some idea about microarchitecture, ISA. So this is the middle is where we will be. We are not going to manufacture any transistors, or we are not going to go into any physics conversations. We'll be somewhere in the middle, a mix of it, right? So I hope you get the context. Once you get the skills, there are different career pathways that one can take. It can be being an FPGA design engineer. It can be being a verification engineer, a layout person. All these skills are required to manufacture a chip that powers your phones, your computers, and many other devices that you use in your day-to-day life. All these careers that I have added here in the slide, these are design tasks. None of these involve manufacturing. Design can be done from anywhere. It doesn't matter whether you are in Sri Lanka or you are in the US or in some unknown country that you have never heard of, right? The location doesn't matter. You can get the thing done as long as you have the skills. And developing that skill is what we need to do. We lack that skill in Sri Lanka. So at Electronics and Telecom Department, we have a focus in this area, digital system design. So we do that. But then again, every year we get only 100 students into our department in our intake, and that's the number. And out of that 100, people will go into machine learning, they'll go into telecom, they'll go into electronic circuit design. So they have diverse interests. And eventually, the number of people who specialize in this area is quite less. And in other universities, they have different programs. So you might know them if you're studying in one of those universities. But eventually, the output, the skilled workforce that we have in this area, it's quite less. And that is what we want to address. To do that, in our chip design roadmap, and we are starting today with the fundamentals course, we want to walk you through or take you through these steps. Number one is skill development. Well, of course, without that, you can't do anything. So we need to study these subject matters, which is what we are starting today. And also, we need to strengthen your mathematical understanding, right? So this doesn't have to be, I mean, if you did maths for your A levels, you might be thinking, okay, calculus and all that. Well, not really. In this line of work, having knowledge of, let's say, linear algebra, Boolean, of course, you'll need to use, and then a bit of number theory. That's pretty much what you need, right? So basic understanding will be okay to begin with. And as we move forward, you will get the necessary skills. So once you get the skills, you need to work hands-on. You need to develop things. You need to apply your knowledge. So what we will do in this course is to combine these two. The studying aspect of it, you learning what you need to learn, and also then you applying. That's where the hands-on work comes in, right? So it's going to be a mix of it. We will be building small digital projects. We'll practice some simulations. We'll prototype a few things. So the end-to-end thing we want to capture. And this is the first of a series of courses that we are planning in this area. So of course, at the end of the first course, which is the fundamental one, you will not be able to manufacture a chip. So I want to set your expectations right. This will be the basics. And at the end of the set of courses, what we want you to achieve is taping out an actual chip, right? Whether that's a very simple design, that is fine. And we have developed a mechanism where you don't have to spend millions of dollars to tape something out. We are in conversations, in partnerships with several vendors in the chip manufacturing area, not the design area, the manufacturing area, where they take a design and they actually put that on silicon. So that conversation is happening right now. And to test things out, we are currently working on one design, which we will tape out. That's mainly handled by the instructors who are teaching this course to you. So we'll do the first test within the next couple of months. We'll have the chip ready and we'll do our own testing on that. So it's a very simple design. And by the time you complete the series of courses, that will be somewhere next year, then we'll be ready with our own trial. We'll know how it works, and we expect you to do the same, right? So these are the two things that we plan to cover in this series of courses. And once you have the skills, you have the hands-on experience, then the next step is to get the industry exposure, right? So maybe with the knowledge, you can go take an internship in a company in this area. We have companies in Sri Lanka. We have companies outside of Sri Lanka. Then you can collaborate in projects with other more experienced engineers, which will give you like a really good head start, like a kickstart for your career in this area, right? So this is our expectation. And at the end of it, what you do, further explorations, the blue box over here, that's completely up to you, right? So once you have the foundation, then you can do so many different things and you can decide what to do. That we will show you the path, and one person or a group of people will not be able to cover everything under the semiconductor industry. That will be your own exploration, and you will be more than capable to do the self-studying, collaborate with other engineers, work in different companies, and get the skills necessary to do the whole further exploration part, right? So this is our plan, and you can see the series of courses that we have planned. We are right here at course number 1, Fundamentals of Digital System Design. Number 2 will be this, number 3, and number 4, and so on. Each course will take about 2 months. We'll have classes on weekends. We'll tell you exactly what the schedule is for this course. And if you put in approximately 8 hours per week, you will be able to cover this. And if you can't put 8 hours per week, maybe you should not take the course right now. Take it at some other point when your schedule is a bit more relaxed. Because we don't want to make any false promises saying that you just enroll in the course and you will be a wizard in chip design. Well, unfortunately, that is not going to happen. You will need to put in the effort. So therefore, our estimate is about 8 hours. That 8 hours can come from anywhere in the week because we have a flexible schedule. We'll have live conversations like this. We'll record them. We'll put it up on our LMS. We'll have recorded theory sessions. We'll have recorded working sessions. So all that will be there to facilitate your learning experience. But the most important element of that learning experience is you. You need to put in the time. So 8 hours is what we recommend. Who is this course for? Well, this course can be for absolute beginners. And one thing to keep in mind, in this course, we will not be able to teach you like a basic programming language, like let's say Python or C++ or Java. That is not our objective, right? So those who are enrolling in this course, we expect you to have an understanding of at least one programming language. You don't need to be an expert, but at the same time, we cannot teach you what a for loop is. Those are the basics, right? So we expect you to have those basics ready. And then whatever is specific or relevant to hardware devices, can be system Verilog, can be any other logic design, that we will teach you. Okay. So I hope the expectations are clear in terms of time commitment. And also before you take the course, what you need to know. Any programming language, most people take Python these days. Any programming language, basic understanding about, let's say, how the syntax works, loops and functions and conditional statements, that level of understanding, then we can work with you to take you step by step up to the point where you are an expert in this area. So I hope that's the chip design roadmap and the motivation behind it, what we are planning to do is clear. That completes our first agenda item. We'll move on to the second one, where Abarajithan, one of our team members and currently a PhD student at UCSD with experience at global companies like AMD and Qualcomm, will be speaking to you about his experience in the industry and a few other interesting stories from the area of chip design. Abba, I hope you're here. We'll hand it over to you.
Hello, can you hear me?
Yeah, we can hear you loud and clear.
All right, great. So, a second.
Yeah, make sure you don't
All
click
right.
Mentimeter. A few other questions are coming up. Abba, go
Yeah,
ahead.
sure. All right. So I hope you can see my screen. And yeah, I think I will also switch off my video to save you the bandwidth. Yep. All right. So, yeah. So I'm here to talk about my journey into digital design. So, and through this process, you might like hopefully get inspired, or like you can maybe figure out that it is not as hard as you think it is, and like you can achieve it too. So that is a like whole idea of doing this, right? So so I did my OLs in 2011. So that is basically like where I started, just like all of you. So you have the very basic, say, transistors, and then you have like some logic gates, and you have truth tables and all of that, right? So when I studied those things, I had no idea what they are used for, or like how they come together, or like where do you put them, like what is the purpose of it, right? So I just like sort of like memorized them, and like what even the teachers didn't know. So like it wasn't kind of like anything useful. So I just it was just for the exams, and I passed the exams, right? Then in 2014, I did my ALs. So in the ALs, I was kind of so I was very good at physics, but then like the only a part of physics that I couldn't do was electronics, right? So you know that you have like 8 questions in the paper, and you have to choose like 4 questions. So like I didn't study electronics at all, and I kind of like omitted that. And even in the MCQ, like there were two questions, I skipped those, right? So I got like 48 out of 50. So like the only questions I couldn't do was electronics back in the day, right? So and I didn't understand any of the BJT, so anything back then, and like it didn't make any sense. I don't know what is the purpose of transistor, so none of that. So the school didn't prepare me for that, right? So it was like all like just doing things for the exam, right? And then in 2016, so like I got into University of Moratua, and in first semester I got ranked pretty high, so high enough to go get into electronics, right? So and then I was wondering, okay, what do I want to do? Like, what should I do? So I did some programming before that, but I didn't want to sort of like do only programming all my life. So I wanted something more challenging than that, right? So then I chose to like go to ENTC, and that is how I got placed in ENTC, which is electronics and telecommunication, right? So before that, like I skipped all electronics in my life, okay, in OLs and like ALs at all, and then I somehow got into electronics. And that is where I started learning about these things. So for the first time, and it was really interesting, right? So in 2017, that is the next year. So this is my in my second semester, you had the first digital design lab, right? So you have an FPGA and you write some code in Verilog to make a circuit. So you make a circuit that can do like night rider light, like you mean what lighting up light bulbs, right? LED. So that wasn't kind of like too inspiring for me because I mean it's something that you can do with Arduino, right? Why do you need an FPGA? Why do you need to design a circuit to do that? Okay, so and it didn't make like a lot of sense because like the Verilog was kind of like weird. So it is a spatial language. Like I didn't understand that at the first time. Okay, so I was used to C and Python. So it looked like C. So I thought it works like C, but it didn't. So it was kind of like I mean I didn't see the whole point of it back then. But then there was another course called computer architecture, and it was taught by Dr. Pascal, and it was really interesting. But it was quite abstract. So like you didn't build anything in that. So he taught about like process and like assembly languages and how things work and how how do you send an instruction, how it comes out and all that. So it was very abstract. It's like say like Alan Turing talking about his Turing machine, right? So but then it was very interesting for me. I took all the notes and I understood it completely, and I was very fascinated by his teaching and the course. And then but I didn't know like how to build it or how it comes together at all. Okay, it was all scattered, right? So then in 2018, we were given the processor design project. So I will talk about it in the next slide. So that is where I got my feet wet. So like now it's like a blank slate and you have to design something in your own and all that. And I absolutely loved it. So I formed a team. We put like so much effort, like several months, like working on it. We got together in a person's house, one of our members' house, and worked every night on this. So and I fell in love with digital design, right? So it clicked for me, like everything, how everything connects together and all that, right? And from at that point, I decided, okay, this is what I'm going to do for the rest of my life, right? So the key part is like I didn't know there is a field like this until I got into the university until 2017. So in O levels, like nobody told me. In A levels, what like by looking at the material, I didn't know like you can do this like, at all. But in 2018, like I found this passion, right? And then like we put like a lot of effort into it and built it and all. And so that led to our final year project in 2019. So where we built like an accelerator, FPGA accelerator. I'll talk about it as well. So and that was like, and it was connected to a real world example, right? A real world problem. So that was really fascinating as well. We spent like one whole year like learning different parts of it and building it, and I improved my skills through that. And yeah, so then through that, in 2020, when I graduated, like after working as a say yeah, after working as a junior lecturer for a few months, I got a job opportunity at a Canadian chip design startup. It's called Lemurian Labs, and they're still there, like they're expanding gradually. So and so I got this job through a professor. So he reached out to me like through ENTC, and he said like, okay, I have seen like your final year project work, and it's really interesting. So maybe would you like to like take this offer, right? So it was really good. Like it was within my field, within my knowledge, and it was quite challenging. So I took the job, right? So I worked for there for like 1.5 years, and the pay was pretty good. So I think this was like just before they like remove the peg or something. So it was like 4 lakhs a month or something around that. So the pay was good and the job was good as well as, and it's like really interesting work. I'll talk about it. And then finally in 2022, I got placed at UCSD for my PhD. And so I'm working in a lab, we work on FPGAs and on say high energy physics, like scientific computing applications. where you like accelerate those applications on FPGAs, so stuff like that. And then in 2023, I got an internship at Qualcomm, so for 3 months, and that was pretty good. And then 2024, that is now like I'm on my AMD internship for 3 months, right? So, and that has been my journey so far. So hopefully I can graduate in the next 2 3 years from PhD, and then I can like probably find a job like in chip design. So yeah, that's the plan. All right. So yeah, so I just want to start from 2018, where like so like I found my passion in like this processor design project, right? So the task that was given to us was, so at this point we didn't know anything about it, like so we just know how a processor works and all, but we don't know like what to do or like how you can achieve it or something, right? So the task that was given to us was like you need to downsample 512 by 512 image. So that means you have an image, a photo, like a black and white, and that is 512 by 512 pixels in size, and you need to like convert that into an image that is say 256 by 256 size. So you have to basically make it smaller. Okay, so that is the job. So for that, like you have to design a processor and like a bunch of stuff. So you have to design and build. Like the first thing is like you need to build a custom assembly language. So like some people like took RISC-V, so which is a good idea. But then in our case, like we wanted to kind of like build everything ourselves. So we went on to design our own custom assembly language. So and like our own instructions and all that. And then we built a like processor, designed and built a processor on FPGA, and then using Verilog. And then we also built an assembler in on Python. So this is a Python code that takes your assembly. So you type your assembly code like in human readable language, and then this Python file will convert that into a binary, right? So into binary, which you can put into the processor. So we built all these things, and we implemented and tested on the FPGA as well. So on the right side here, like you see entire processor, which we designed. So Abrutech is our like group's name. So we gradually started and like we added features, more and more features, and made it custom for like image processing and all. So it was a really fun project. Like it took about 3 months, and I think we had some problem, probably some strike or something. So we got like a one month off. So in that time, like we built the whole thing. So yeah, this is like, so the goal was to do like the goal was to do like a black and white image, but we did it for like color images as well, and we added like way more many algorithms, right? So here like this is the idea. So this is upsampling, right? Like you go from a smaller image to a bigger image, right? So this is one of the things we could do, and this is what the assembly looks like, right? So this is our custom assembly language. So you have like each word is like 1 byte, and then you have like what yeah, so we define this language ourselves, and then the Python code can process this, and it converts it into a binary, right? So all that. So it was a fascinating project. So yeah, and this is like applying a sort of like a filter, like something like you might have in on Instagram or something. Okay, so you can apply a filter. This is our team, 4 of us. And we also built a simulator, that is another Python program that can go through this process step by step. And then like it tells you what are the registers at different levels and stuff like that. So then it helps you to debug. So it was so we put like way more effort than we should have. And that way like we learned a lot. And like and it helped like all of us get into like different internships and all like related to this project as well. So it was a really good project. And then in 2019, this was our final year project. So this is vision-based traffic control. So the idea is like now you have traffic signals in Sri Lanka, and yeah, so you have traffic signals in Sri Lanka, and these okay. So the way they generally work is that you don't have, say, any kind of like a feedback loop. So they have fixed timings, right? So like in every junction, you have like maybe 30 seconds and other 20 seconds. So something like that. So the green will stay on for 20 seconds and then you go to red and then it cycles around and then the green will stay for 20 seconds, right? So, and this is usually set by the civil engineers like every 2, 3 years. So, but then like it is not very optimal, right? Like in the morning, you have like a big rush on one side of the road and it is still 20 seconds and everyone is waiting, right? In the evening, there is a big rush on the other side of the road and like it is still 10 seconds and everyone is still waiting, right? So it's not very optimal. So in some places in the world, they're experimenting with this vision, like different type of traffic control algorithms. So, and some of them are like you have like maybe a wire in the road where pass. So like, and they know how many vehicles are passing based on that. So, and one of these things that now like is picking up is vision based. That is, you have a camera, and from the camera you see the vehicles. So now you know if it is a big lorry, it will take long time to pass. If it is a, can give different timings to different sides of the signal. So that is the whole idea of this. So how does it work? So the way, like, I mean, we designed this system is basically like, let's say you put a camera over here in this traffic arm up here. So you will get a view like this. So we put a, like, we actually built like a small device and put it over there to get these photos. So, and so you get a view like this. And from this, you like look at, okay, like these are the vehicles. And how do you know these vehicles? So for this, you run like a CNN, right? Like we used YOLO V2, so which is an AI model. So you run this on this image, and then you get these bounding boxes. So you know these vehicles are there. But then you also need to track these vehicles. That you need to know whether the vehicles are turning left, whether they're turning right, all that. So you need to track the vehicle. And from that, you count how many vehicles are turning left and right. So from that counting, you put that into an algorithm and like which we designed. And then that will give you the phase timing of how much time for each side, right? So it was a pretty big project and like it spanned like many areas. So on the FPGA side, okay, so the reason for FPGA is like if you put it on an FPGA, you can do this on a GPU or something, but then you can't put a GPU in every junction in Sri Lanka if you want to, right? So hypothetically, so you can't do that. And or else like you can't say if you put it like Jetson or something, NVIDIA Jetson or something, then you will have to buy like a lot of Jetsons, and they are not very rugged. So like they don't work in like this, what in rain and all these things like dust and all these things, right? They are not they're only used in like lab environments, right? So then FPGA is something that you can use in all these places. So like people send FPGAs to the space and all, right? So that way, like if you can accelerate this on FPGA, then you can do this, right? So that is the idea. So for that, like we had to design and implement an accelerator that can accelerate YOLO V2. So to process this on within the time frame, within the real time, right? And then like on the machine learning side, so we had to modify and improve YOLO V2. So the model. So you had to modify the like take a pre-trained model, modify it, and then train it on Sri Lankan data set. So to identify three-wheelers and all that. So we did a bit of work on that. And then on the traffic side, we had to study civil engineering, like, and we had to do some traffic algorithms, and we had to simulate it on some like simulator. So we had to do a bunch of stuff like that. So it was a like quite big project, but it was very interesting because it is a practical problem. Like, so you know how through this project we kind of so you have like a real world problem and what are the constraints and how do you kind of build like design something that fits these constraints and how chip design can directly impact your like real life, that is like people driving on the road. Okay, so it's like an interesting project where everything comes together, right, rather than just being like an abstract, okay, I built an accelerator, right? So that way like we learned a lot and like we enjoyed this project a lot. So and for more details, you can find this in my blog. All right. So this is kind of like an yeah. So this is kind of it worked. So you have like if you put it on these four sides, then like you get it over here. And we used for this we used so there's a question about what is the FPGA model we used for the previous project. So that was an Ultra D2, I think 10 or something. It was a very small FPGA, but like even that whole processor took like I think like 2% of the resources, right? So it didn't take like much space. So you don't have to worry about that. All right. So over here, mm, yeah. So this the right. So here the idea is like you get all this, but for this we used a different FPGA, so which is Zinc or GC102 or something. Yeah. So that was so the now this is a different kind of a chip, where you have like a, so an FPGA is a flexible chip, right? So that's the whole idea. So thing is like you can design a chip, and you will learn about this in this course. That you can design a chip, you can design a circuit where like you have your logic gates and everything you put together, you make a circuit, and this circuit you can implement into this flexible chip, which you call an FPGA, right? So you can put it on this flexible chip, and then what happens is like it is just like programming in Arduino, but then instead of giving like a software code, you are giving a hardware design, right? So you give a hardware design, and then the circuit will like organize itself into the chip, and what you wanted will be created, right, within few seconds. And then you can like run like I mean you can make a processor into that, and then you can talk to the processor, you can give like different code, and you can run the processor, and you can do stuff like that, right? So or else you can build an accelerator, machine learning accelerator, you can do stuff like that as well. So that is the idea of an FPGA. So like if you are doing chip design, so FPGA is something that you can quickly build on, and like you can build your circuits and you can experiment quickly, right? So this kind of an FPGA has like two parts. So one is it has a processor and it has an FPGA, right? So this is an ARM processor. So what we do is like you take an image and pass it to the this whole system, which is one chip, and it first goes to the FPGA, and then you do like you have YOLO V2 running on that, and it will do like vehicle detection. So you will finally get like bounding box coordinates, like money running through that, and those coordinates will come to the processing system. So over here, like we have C code, like our own C code, which will extract the bounding boxes, and it will track the vehicles, will measure the flows, and it will have like calculate timings, do all these things, and give the timings as output, right? So that is an entire flow. So yeah, and you can get the more details from here. All right, so that was a very interesting project, and so through that, so after I graduated, the next year, like after I graduated, so like I got contacted by Professor Arjuna from Florida International University. So he was a partner. He is a partner in Lemurian Labs. So when they started this company, they hired like some top professors in the world, and he's one of them. So he's a legend in his field, like we are like in signal processing and all. So he has done like a lot of good work in that. So then they hired him as they took him into the very first group. So then like he talked to them about me, and then like he reached out to me as well. So then like basically like he said like I mean I have seen your previous project and all. So like which is ML exploration, building an accelerator and all. So we are doing something similar but commercial. So maybe like you might be interested in that. So it was a like an interesting proposal. So I joined the company. So so the kind of key idea was like they were building an accelerator using something called the multidimensional logarithmic number system, MLDS. So so the idea is like you will learn in this course about like how do you add numbers digitally, how do you build circuits to add numbers, and to build ALUs and all that, right? You will learn all that in this course, right? But then the simple addition, like addition and multiplication. So the problem is like the multiplication takes a lot of area in a chip, right? Because for that you have to do like a lot of additions. So like if you are doing like a 32-bit number, then you have to do like 32 additions like one after the other to do a multiplication, right? So you will learn that in this course. So that is a quite complicated thing. So, and it takes a lot of area. So what people do is like they have been looking into different types of data, like can we represent things differently. So if you do like a lot of math, and you might like come up with something like say logarithmic numbers, right? So then the idea is if you multiply numbers, it becomes addition, right? Because it's logged. So that is a basic idea. So if you do that, you can reduce the area like significantly. So that way you can put a lot of multipliers within the small area. That way you can like run the AI very fast, right, within a short time. So that is the idea of this. So yeah, so I was the first hire of this company as an employee. So then I had to set up like a lot of things, and I built the matrix multiplication ALU with MLDS, and I also set up CI/CD, so which is like the continuous integration and continuous development, right? So that is like GitHub Actions to like automatically test a chip and like do all these things. So I learned a lot from that experience, and it was really good work. Yeah, and it paid quite a lot as well. Like it was like then by 2019-20, it was 400,000 a month. So it was pretty good for a good job. So like the idea is that you can find like jobs that pays a lot in this field, right? So yeah. So in 2022, in 21 I applied for PhD, and 22 I got placed. So in UCSD, that is UC San Diego. So like I'm working in Kastner Research Lab under Professor Ryan Kastner. So, and he has written a famous FPGA book. So like if you're into FPGAs, you might know it. Like it is called Parallel Processing with FPGAs. So that's kind of the Bible for, say, HLS programming for the people who are getting into HLS, right? So yeah, and in the lab, we work on FPGAs and ML acceleration for scientific computing and hardware security. So scientific computing means, so you might have heard about CERN, right? So CERN is they are in like Switzerland and France. So and so it's like in Europe. So that is their scientific. It's like what they do a lot of physics experiments. So you might have heard about the God particle. Okay, it made like news all over the place. Like there's something called the God particle, that is Higgs boson. And then like so they are trying to find the grand unifying theory and like all. So those are the unsolved problems in physics, right? So and these people are trying to solve it in Switzerland, right? So how they do that is like they have like you have a massive tube like 27 kilometer like long under the ground, okay? And in this tube like you have protons. So this you take a proton beam and you accelerate it through magnets. You keep on accelerating it to like really high speed, like 99.999% of like the speed of light, right? And you accelerate it to that speed, and then like you do it for two proton beams, and you make them smash, right? Hit each other at a particular point. So when they smash, like you get like a billions of weird particles. Okay, like you have like a random particles coming out of it, and you take a photo of that. Okay, like using something called detectors. Like they have massive detectors. Like these are like 10 stories high underground, right? So these detectors like take photos of that, and then like you process it, and then you see if there's like a new physics particle, or like you see like whether our models are correct, physics theories are correct, and like if there can we discover more theories through this. So they do all this work, and they use this FPGAs a lot, and they design their own chips to do this work, right? So we are working with them. So for to do this, make this possible. And similarly, like speaking about science, you have like you might know about Perseverance. That is the rover that landed on Mars recently, like last year or something. So it was built up by NASA, and like they sent it all over there and to land it, right? So and it was a massive thing. Like it has, I think, like several tons, and like it was a huge thing. So when it landed, to find the landing spot, so they used an FPGA. right? So they used, so I told you in the previous project, I told you about like running a ML model for object detection through FPGA. So they did something similar. So then they built their own model and they ran it on the FPGA to find the landing spot, right? So because you have only like a few minutes to find it, and then like the back and forth from Mars to Earth is like too long, right? So we can't kind of like help the rover; it has to do it itself. And even after landing, what they did is like, because the FPGA is flexible, it's a flexible chip. You can like remove a existing design, an existing circuit, and you can put a new circuit, okay, immediately. So you can switch it back and forth. So you don't need to make multiple chips to do that, right? So that way they switch it off and they put a new chip, new circuit, and that circuit is helping the Perseverance rover to drive around. So that is self-driving, right? So and they are using like a Xilinx FPGAs, right, which you might have in your lab. So like what if you take our next course, like we will be giving you the FPGAs to do some work, right? So yeah, so all that is chip design, and all that is happening, and all the like um, our satellites, they use FPGAs. So they have their custom circuits running on them. So that way, like you have a lot of FPGA design going on in the world, right? So we work with them and we help them to build this stuff. So I have been building this framework to help them with that. So this framework has like a Python front end, so where people can build neural network models, so scientific computing models, and then like you can like you what give a command, and then it will generate system verilog, so which you will learn in this course, right? So and it will generate system verilog designs for circuits, and then to put that circuit on the FPGAs, you need to put that through some software, which also you will learn in this course. And to automatically do that, you can write some ticker scripts. So it will automatically generate the scripts as well in this particular like framework. And then you will have a C firmware which talks to that and gets it done, right? So we do all these things. So and all of them work together to help things possible for physicists, right? That's the idea. So and this is our paper. It's currently under review, so you can check it out. Yep. And finally, like about my internships at Qualcomm and AMD. So I can't give like a lot of information about them, but I can tell like stuff like this. So like in 2023, last year, it was a 3-month internship at Qualcomm. That is the GSOC integration team. So if you don't know about Qualcomm, Qualcomm is the company that makes more or less like all the chips in Android phones, right? Like in all the SoCs in the Android phones. So if you have an Android phone, which is not an iPhone, okay, if you have Samsung or anything, then I think Samsung might have moved now to their own socks. But like the phones that came like few years ago, all of them are using Qualcomm SoCs, right? And all the modem are made from there. Like even in all the phones, even in Apple phones, like everything that when you make a phone call and everything, so all of that is going through a Qualcomm chip in every single phone in the world, right? So they're doing all that work, and GSOC integration is basically like so it's called a system on chip. You have a big chip with the little parts of like different say a processor, like a GPU and all that, right? So and these are not little, like these are also like big designs, massive designs. So then you have to like and they are built by different people. Like you have people of hundreds of people, you know, like in some teams like maybe like 1,000 people or something. So they build like an entire processor, and then like you have to put everything together into one chip, and that is the work of the GSOC integration team. So I work there. So and I've been working with the like I work with the in-house buses. So how do you send data between these chips, between these designs? Okay, how do you move data fast? So and like what are the problems with that, and like that. And then I built some automated tools to generate a custom IPs as well, custom chip circuits as well. So and the pay was about $8,800 a month. So that is in Sri Lankan rupees like 26 lakhs per month. So this is for an internship, right? So I'm telling you like how much you can earn through this field, right? If you choose to go through our courses and like if you choose to get into these fields, so you have like a lot of money going on, right? So yeah, and then this year I'm working on AMD for 3 months. So AMD has something called this AI engine. So they have kind of a new architecture where you have like multiple small processors, all like full process, right? And all of them you have to manually move data between them and all. So and and we have been building software tools to support that, and I have been benchmarking some algorithms to make it work and all. So and finding bottlenecks of how to move data, where does it get stuck and stuff like that. So it's pretty interesting. And the pay over here is like about 9,200 a month, 9,300 a month dollars. So that is 28 lakhs per month in Sri Lankan rupees, right? So these are the kind of range like you can expect, right? So this for internship, right? Okay. So finally, what are my like takeaways from this journey? So I started by skipping like electronics, right, in O levels and A levels. So I didn't understand what it's used for. So it wasn't kind of like it wasn't taught in relation to the real world, right? So which is why we decided to make these courses for you. So especially this course and the next course. So where we want you to understand like how these things are related to the real world, and we want to kind of like give you like complete examples. Okay, complete examples that you can build by your own hands. So that way you don't have to go through the uncertainty that I went through, right, in the past, right? So so we'll tell you like so what in the next session you will see. So we have a very interesting project. So just by starting with only knowing about like logic gates, okay, you will see how you can build your own circuits and you can kind of like put it into a real world example. So that way, like you will get like lot of confidence, as well as you will know how everything works, right? So the stuff that I had to go through like in the dark and like what like kind of figure things myself, and like I would have got lost anywhere. Okay, so to remove all that uncertainty, like this course will be very valuable for you, right? So I didn't know about this field until semester 2 in Mortua. So I didn't know that there's something called chip design that you can like, and this one, and there are job opportunities. I knew nothing about that, right? So this, like, so the reason we are doing this is for you to give that exposure. And the next part is that each of my projects propelled me to the next big step, right? So this is kind of the key point. Like if you are getting into like digital design or like even software, your projects are very important, right? So you find some interesting projects, spend a lot of time into it, and like make it like really good, and like maybe rebuild it a couple of times. So that way you will learn a lot, okay, through that, and you put it on GitHub as like an open source thing, so the people can find it out, and you can put in your resume. You can put a link in your resume, so that way people can find out, and then that will help you to like jump to the next step, right? So we through this course we are going to give you that boost by giving you like a fairly complex real world example. We will build it together through the course, right? So at the end of the course you will have something on your GitHub and something that you have built in your hand by your hand completely, right? And if you take our next course, you will take like a lot of you'll build like 8 or 9 multiple real world examples, like with increasing complexity. So that also will help you to kind of launch yourself to the next step. And then after a point, so after a certain point where you have like good projects and like you have some background, then you start getting opportunities yourself, right? So then you don't have to like worry about it. So people will reach out to you and you apply to some companies with your projects, and you will get picked, okay? So and for very high paying jobs, so all that. So so the reason for this is this hardware is very hard, unlike software, right? So you have like a good job security. So if you take say web development or something like that, then people can actually learn it by maybe like taking like a 1 week course online. So you learn React and you make a project in React, you put it on CV, and then you are like set for you apply for companies. So because you can do that, what happens is like you have like a million people who have React on their resume, right? So and then it's very difficult for them to find a job, and even if you find a job, it's very difficult to keep the job, right? So but because like you have like a million people outside who knows React, but in hardware, like you don't have that. So you have only like a very few people outside who knows these things, who have gone through this entire journey, like that I explained. So we are helping you to go through, right? So when you come out, like when you take these courses and when you come out on the other side, you'll be like one of the very few who knows how this works. So and given that like the chip design market is going up and up, and like now they are like trying to put this on everything, and like you might know like Nvidia became the world's largest company. Okay, so Nvidia makes nothing but the GPUs, right? So they make nothing but the GPU chips, right? So and you have other companies, you have like Apple, which makes everything. Like you have like phones, watches, and like MacBooks, and you have Mac OS, and like you have all of that, right? So Nvidia was valued more than Apple and more than Microsoft. Like Microsoft does like so much more, right? So the tide has turned towards chip design. So then like it's better to be in a position where you are one of the very few who understand this stuff, and you who can do this stuff, and like who have projects demonstrating that you know this stuff in and out, right? So that is the whole plan of this. And finally, like it is not just me. Okay, so it's not like I'm exceptional and like I got this job and like it's like 27 lakh, and like no, it's not like that. Okay, so you have countless people who have been like who are getting these opportunities, right? So through in UCSD, I have like a lot of friends who came for masters here and found internships and then found jobs. So my roommate, like the guy I lived with for like 2 years, so he found a job at Nvidia now, and he's working there. So this is $150,000 a month, a year, right? So 150K a year plus stock. So that is in rupees, like it's 37 lakhs a month plus stocks, right? So and that is your starting salary in chip design in like in Nvidia. So then you have like a lot of people like who got jobs in Qualcomm. So that is like slightly lower, maybe like 25 lakhs, and then a month. And then you have like I have friends in Qualcomm, then people in Apple who are doing chip design. Okay, so and they're getting similar salary. So the thing is like people are coming here, and like you have like a lot of opportunities like for this. And even from Sri Lanka, you have a lot of remote opportunities, right? So it is a bit hard to get to look around and find it. But then there are remote opportunities. You can still make like a lot of money by getting into this field, right? And with job security. That's the idea. All right. Thank you.
Right. Thank you, Abba. I think that was quite insightful with the personal journey and where you are right now and from the insights from the industry. Let me share my screen again. So to break the ice, we have one question coming up on Mentimeter. I hope you guys did not log out of the initial code that you added. Yeah, my screen sharing is paused for some reason. Let's see. Okay, so this is where we stopped. I hope you got quite a bit of insights from the talk that Abba delivered. So anybody, I mean, anybody in the sense now, you saw where he started, just like you and me, doing O levels in Sri Lanka, doing A levels, and then moving forward from there. So quite a bit of things that you can take away from that. It's if you put in the time and effort, it's not an impossible job. So quite a few people do that. In fact, our neighbor people from India, a lot of people go into this domain. So why not us, right? So why not people from Sri Lanka? But the problem that we found was that many people don't have the resources, don't have a proper guidance, and that's where we thought from ENTC we'll provide that. So this will be the first step, as I mentioned earlier, of a series of courses, and we'll see how it goes, how many people take it, and at the end of it, our objective is to show success stories of people who took the courses and then went on to do fantastic things. So having said that, I hope I gave a small prelude until you joined, if in case you logged out. But yeah, so this is where we stopped with the third question. I think we can see the leaderboard of people who are actively taking part in the questions and answers. We'll see who is leading right now. Looks like it's Malinder. Okay, very close competition so far. We have one more question coming up before we go for the next speaker. Let's see what that question is. How many people do we have connected? Is it 70 plus, right? More people are coming in. Right. Well, I hope you're ready. We'll see what the next question is. Okay, so the question was, which company is considered the market leader in EDA industry? When you look at the whole chip design industry, there are manufacturers, there are designers, and there are so many different roles in between. And the global supply chain is truly global, where even if you take like an SoC, different components come from different vendors, and then they eventually end up sitting on the same die or on the same chip. So it's a huge area, and out of that, design automation is one aspect of it. And Synopsys, who has a presence in Sri Lanka as well, is the market leader as of 2024. That's this year. So speaking of Synopsys, our next speaker will be representing Synopsys. He's Dr. Achinti Roshan, the staff program manager at Synopsys Academic and Research Alliance, a graduate from the biomedical engineering department at Moratuwa, and completed the PhD at Moratuwa in collaboration with Imperial College London. So we have Achinta here to give some remarks about the domain and also representing Synopsys. So we'll get an industry perspective from him. Achinta, I'll hand it over to you.
Thank you, Subodha, for giving me the opportunity. So, as some of you answered correctly, Synopsys is the global leader in EDA. So, EDA are the people who are providing these tools for IC designers and also manufacturers to make the process easier. So, we have around more than 20,000 employees globally, and we have 200 plus people in Sri Lanka working on design verification product. So that is actually part of the ASIC design flow. And talking about, Synopsys is a critical part of the semiconductor industry, and it is a high time to learn this semiconductor and get into semiconductor industry, because there are multiple global investments happening. There's this US chip act, 15 billion plus US chip passed, and they are making many initiatives. And the currently in 2024, 2023, it was semiconductor industry is a 500 billion industry, and now it is in 2030, we expect it to grow to 1 trillion. And also, KPMG Semiconductor Outlook explains like the biggest issue now the semiconductor industry face during next 3 years is the talent issue. It is not easy to develop IC design engineer or talent in a semiconductor industry. So and it is very hard to find. If you learn this, you will have many job opportunities. So, and it will be important to Synopsys and also the customers of Synopsys like Intel, Nvidia, and all these companies, as Abba explained. So this is a broad industry, and and as Dr. Subodh explained, the steps by steps, the journey that you can go through this, digital design system through this series of courses. If you go through it, you will be with this expected talent. You will be one of the talents that is expected from the semiconductor industry, and you will be picked by one of those companies for sure. And most importantly, regarding this particular module, it is very important because these are the basics, right? So, if you want, actually, if we are recruiting at Synopsys for a product validation engineer for some of our verification, we actually test these basics. So, I mean, this is the first step. And if you do this course really well, I think you have a good future in this. So wish you all the best, and thanks ENTC and all the lecturers for delivering this course. Good luck. Thank you. Thank you.
Thank you, Achinta, for that. I think I started sharing the wrong screen. Right, there we go. Okay, so now you heard multiple perspectives from the industry, and I hope that reinforced the narrative that it's a huge area, and the main problem that we have is a lack of people, and this is one of the steps that we are taking to address that problem. So from our side, that is the motivation of developing these courses. The leaderboard after the Synopsys question has changed a little bit. So this is the leaderboard right now. We are halfway through our quiz. We'll see what the rest of the answers are and who will end up as the winner of the quiz. So that brings us to the last session of our conversation today. That is the course introduction. I mean, what you can expect to see from the fundamentals of digital system design course. I'll walk you through what we plan to cover. If you have any questions, this is the same Mentimeter link that I added. So please stay connected. We will have a Q&A slide at the end of the Mentimeter quiz. At the same time, if something comes to your mind, you can drop that as a message in the Zoom chat. Even now, I have replied to a few questions that came through the chat. So we'll keep an eye out and we'll clarify those doubts. But at the end of the conversation, our presentation, we will allow you time for a separate Q&A as well. So the history of these courses that we are doing right now, this was started back in 2020, mainly with Abbas leadership. This was an initial course on System Verilog. The first iteration was free of charge with few initial examples, and pretty much everything was done by Abba back then. And that got really good feedback. So you can see some of the feedback that we received. Then we thought, why not give it with a certification as well? Because the first one was mainly like an online webinar series. There was no certification from Moratua or anything like that. It was mainly an effort to popularize this area among students, mainly from our own department. Then we started this course in 2023. That went by the name of System Verilog for ASIC, FPGA design and simulation. So from the 2020 course to this one, the one that we did last year, we got Synopsys on board as a sponsor. They very generously agreed to give their tool set free of charge, which can cost millions of dollars if you have to buy them. That exposure was given to students. And then we looked at better coding practices. We had hands-on examples of digital systems that we designed throughout the course. This is what we did in 2023. Then at the end of this course, the 2023 one thing we realized that the starting point for digital system design should not be this course. So this we initially thought to be a beginner's level course, but in fact, we got feedback from the students that they had a hard time understanding because they did not have some of the fundamentals. Therefore, we thought of having this course as the second course. And we look deeper into what fundamentals we need to be successful in the series of courses. So now you can see the progress, 1, 2, 3, 4. Number 2 is what we conducted last year. Some of you here in this course, you might have taken course number 2 last year. And if you understood that properly, then perfectly okay. You don't have to take course number 1. But let's say you struggled, you could not complete the course, then taking course number 1 can be a good idea. And those who did not take course number 2 last year, well, then no problem at all. You are now at the beginning. So in this course, we will teach you the fundamentals. Then building on top of those fundamentals, we will go into course number 2, 3, and 4. So right now we've completed one batch or one intake of course number 2, but now we are again going back to the beginning, starting with the sequence. So you can see these courses being advertised on our websites one after the other. So when we go, let's say when we come towards the end of the fundamentals of digital system design course, we'll start advertising for the second one. So that's why we said that it can take about 1 year, maybe 10 months to complete all the courses, 2 months per course, 4 courses, and then a gap in the middle as well, right? In between courses, because you cannot have classes every weekend. We'll have gaps in the middle, right? So in the meantime, we will also give you other study material to enhance your knowledge on certain aspects. For example, C++, especially if you're planning for an internship or a job at Synopsys, I believe, Achinta can correct me if I'm wrong, C++ will be one main concern, one skill that you need to have. So we'll give you those background knowledge in terms of what other skills that you need to improve. So there's a lot of materials to cover them, even online. So we'll guide you in the right direction. But our main focus will be these courses that we go step by step and get you ready. So you go from the design to the tape out, and at the same time, you get the industry exposure as well. Right. So having given you the outline about the 4 courses, let's now dive into the outline of this course, the Fundamentals of Digital System Design course, what you will be going through starting in 2 weeks' time. So I'll go day by day, what you will cover. When I say day, this can take, well, I told you that in the beginning of this conversation that you will need about 8 hours, right? So in fact, you can consider this as a week, like week 1, because day 1 kind of implies that you do this on one day. That is not the case, but we plan this for the lecture slots that's why you see day 1. So in the first lecture, we'll cover this, second one, we'll cover that, but you can take like a week in between your other engagements and complete them, right? So they outline what exactly the schedule, because some lectures can happen back to back, some can have a break in between, allowing you more time for self-study. So that outline will be given to you. Right now, I will tell you at a high level what the content is. So I'll use the word day, but please don't be confused. These are lecture days, but you can take a week or maybe even longer to cover some of those concepts. So on the first session, so today is the session for everyone that gives you the background, right? So let's call it 0, day 0, that's today. When you come for the next one, we will start covering the fundamentals, okay? So on the first day, we will not be starting on the project. The project will start on day number 2. We will initially do the basics of digital versus analog design, binary arithmetic, logic gates, HDL design, and test benches. So on the first lecture, we will cover this. And once you have that, from day 2 onwards, we will start to look at how do you apply them in a project. So if you have taken our previous courses, you know that from the very beginning, we start and we get you to work on something hands-on, and we teach you the concepts while you're working on that project. That is one of the main teaching methods that we have used, and we have received quite good feedback about that. And so we are sticking to it. It will not be the case that where you learn theories for, let's say, 4 days and then you do the project at the end of the course. Well, that is not the case. From the second day onwards, you will get to know what the project is. In this case, it's going to be a traffic light controller. And then you develop the concepts, you learn the theories while you work on developing the project. Okay. So day number 2, our focus will mainly be on combinational logic design. These topics will cover that. Then in day number 3, we will focus on the sequential logic design. because one critical aspect of a digital design is the timing component. So sequential logic design is required to facilitate that. So we'll cover these topics in day 3. In day 4, we will start putting things together, right? So now you learned in day 2 and day 3 combinational and sequential logic design. Then you will combine them, will synthesize this in an FPGA. We'll see them in action, right? Then in day number 5, you will apply this for your project, for your traffic light controller. Because now in day 3, 4, 5, you made the building blocks that are required to develop your project. Then from day number 5, we start combining them. The way that we model a traffic light controller, you might have seen this, the most common way is a finite state machine, right? So then by taking those building blocks and plugging them into this FSM, in that setup, you will start to combine things to develop or finalize your traffic light controller. That is what will happen in day number 5. When we come to day number 6, we will start optimizing things. Because our first step is to get something working, and then later we kind of criticize our own design, and then we try to identify what are the missing points, and then we optimize it, right? Well, maybe not missing, let's say not optimally implemented, right? So that is what we will do in day number 6 and day number 7. So at the end of it, you will have a functioning traffic light controller, and by developing that, you would have learned all the basic components of digital system design. Okay, so I hope you got an idea about what you will learn in this course. This is a very high-level overview. I spent only a few minutes, but we'll go into detail with this high-level overview in the next few weeks. Now that you know what you will learn in this throughout the 8 weeks, let's dive into the course logistics. While you are developing this project, you will have 4 main submissions. Because if you don't work on something on your own and then you submit it as an assignment, we don't know whether you did it or not. That's how we evaluate you, and then we decide whether you are eligible for the certificate or not. Because like I said, enrolling in a course doesn't give you the skill. The skill is obtained by working on things, learning things and applying them, right? So our way of assessing whether you completed them, whether you applied, you learned, is to get the assignments for you. So we'll have 4 assignments while we develop the project. And like Abba said, we'll be working with you on these projects. So whatever you do with us, that is what you need to submit. There's nothing new. I mean, we will not be saying that, okay, you learn this theory, you are now getting a question, you go and you build it and you submit. That is not the case. We are building these things with you. You need to follow on, keep up, learn it, and then do a bit of your own creativity, and then you submit. Okay. And for you to be eligible for the course completion certificate, you will have to complete all 4. It doesn't mean that you need to get a 100 grade. I know that if you are a university student, you are very much familiar with A plus, B plus, or whatever. In our grading, it will only be pass or fail. And for you to pass, you only need to put in a genuine effort and then show that you learned something. That's it, right? You will be not getting a letter grade. As long as you pass 4 out of 4, you will get the certificate from University of Moratu. All right. So that's the evaluation criteria. And today you heard from Abba and myself. You did not hear from Dinet, Supun, Tuaragan, Jazuli, Uvindu, or Kitmin. You will hear from them as we move forward. So it's a combined effort. All of us are chipping in with different aspects of this course. You will meet these lecturers as we move forward. All of them are graduates from ENTC, as you can see, but living in different parts of the world. Abba from US, Dinet from Australia, Kitmin from Canada, and everybody else mainly based out of Sri Lanka. So this will be the team delivering the experience to you, and we hope you make the best out of it. A few other final remarks, and I'll spend a bit of time about the next steps as well after this slide. So it's designed to be outcome oriented, as you saw. We'll start working on the project from the very beginning. It's fundamentals taught with real world experience. And this curriculum, what we are teaching to you, it's custom made for this course, right? So even at ENTC, we teach parts of it, but this flow is not there right now. Okay, so we are making it available for the first time for those who are taking this course, and we hope you take the best out of it. The content will be made available to you through a learning management system. The course will be conducted in English. If you have any trouble understanding, our panel of lecturers are multilingual. I mean, not one person is multilingual. The combination is. So therefore, if you need any explanations, we will be able to provide you with that. We'll have a mix of recorded content as well as live interactions like this. So through that, we expect you to cover the content. Typically, we will have the live conversations on Sundays, but we will publish the entire schedule in advance so that you can mark your calendars and then take part in the live sessions. This is a sample of the certificate that you will be receiving. The content is, of course, different. This is for one of our previous courses on microcontroller-based system design, but the titles and the program outline will be different, but it will come with the fundamentals of digital system design content. But this will be the outlook of the certificate that you are receiving. Okay, so what do you need to know or do moving forward? Before I get there, I think there are a couple of questions. Okay, the questions are a bit long. So since I'm presenting the slides, our other team of lecturers, if you can go through this and understand the questions, that'll be helpful. It's not very short, so quite a bit. Okay, that you can't do because these are direct messages to me. All right. Well, no choice. Let me spend some time reading this with you and then we'll answer. The question is, which programming languages are essential for understanding and working on course-related topics? I mentioned this in the beginning. As long as you have an understanding of at least one programming language, then you should be fine. Any other hardware HDLs that we will teach you. Second question is, will we be provided with learning materials and instructions for hardware description languages like Verilog and VHDL? Yes, you will be. What is required for the fundamental course will be provided. And when you go to course number 2, you will get more information. So if you are coming to the course expecting to learn system Verilog from A to Z, well, that is not going to happen. What we will teach in the fundamentals course is the content that is required to build the traffic light controller. Right. So when we do that, we'll cover the entire periphery, but it will not be covering A to Z, everything. So course number 2 will do a little bit more. We took this approach because if we sit down and teach you syntax and the concepts behind that in one course, you will not know how to apply it. And if you don't apply it, the learning experience from our experience, that learning experience is not optimum. Okay. So that's why we have structured the courses that way. Question number 3, are there any specific hardware requirements for our laptops to run the necessary software for the course? Well, not really. Your laptops will be just fine, the usual ones that you have. So yeah, that should be able to manage the requirements that you need. So the panel of lecturers that we have, I hope you got the questions. I'll drop that in the chat so that everyone can see. If there are any corrections to what I said, please feel free to jump in. Okay, one request to re-show day 1 through day 7. Sure. This recording will be available as well, so you can watch it later. But I'll keep those slides shared while we answer the rest of the questions. Question is, I'm an undergraduate from Wayamba University. Do we get placements in industry? Because I've already enrolled in FPGA designing in Udemy and waiting. Okay. Right. Now, our objective is to give you the skills and make you eligible to face an interview. Okay. So we cannot say that you will get a position. What we can say is those who pass the courses, you will get called for interviews after your CV is screened from the industry. So what we do is we say that, okay, these people have covered these topics, they have passed the modules, and we send the CVs. That we will do. Once that happens, passing the interview, well, that is not something we can do. That is on you. You'll have to show that you know the skills, you know what you're talking about, and then get into the industry. Okay, so it's we do our part, and if you have grasped the content properly, then you will be able to get selected from the interview. So these internship placements will happen next year, because at the end of the first course, you will not be ready to go to the industry. It's the foundational course. It takes some time. Once you complete the series of courses, that's why we said about 10 months to cover the rest of it, and then you will be okay. So the way to think about is, we mentioned this in one of the videos as well that we set out as promotional materials. You can, if you're familiar with the concept of a minor specialization. A minor specialization is, let's assume that you're enrolled in a degree program right now. While you cover that content, you earn a minor specialization in another area. So that other area in this case is chip design. Let's assume that you are a software engineering undergraduate. Then you get the chip design knowledge. You have the SE background. With that, you have a minor specialization, which you get through these courses that we are offering to you. And that's a value addition for you. And through that, you can even take your career into the hardware aspect. And the fact that you have a software engineering SE degree, that qualification matters, of course. And that knowledge, things like object-oriented and other modular software development, that will definitely help you in that domain. And the rest of the languages as well. So that's the way that we envisioned the minor to help you. So if you're enrolled in a different degree, you can take this, and then the combined knowledge will definitely help you. I hope I answered the question. So the direct answer to the question, do we get placements in industry? You might, given that you pass the interviews. Okay, so we cannot say that, okay, this person is here, they covered, they went through our courses, please hire this person. That will not work in Sri Lanka. That will not work in anywhere else in the world. What we can do is give you the skills, and the people who pass the courses, put your CVs in front of the industry, and then the recruitment is a business between you and the company. Right? So I answered the same thing in multiple ways. I hope it's clear. Second question is covered. Yeah, the next one is a copy paste from me. Is there any discount for undergraduate students? Yes, there is. I'll get to that. I think the next question about the person being a software engineering student and whether is it possible to get a chance in this field without electronic engineering background, and I think we answered it. The short answer is, if you are a software engineering student, you don't have electronic engineering background, yes, it is possible to go through this. We'll be giving you the hardware specific knowledge so that you can continue. Next question is, do we have to participate physically for the course? No, it's completely online. Typically, the last day we have an in-person session. It's not mandatory. You can come and then interact with the lecturers. That we do because students request us for all the other courses that we had something similar. But to cover the content and get the knowledge, it's all online. Will courses 2, 3, 4 continue after course number 1? Yes, they will continue immediately after course number 1. By the way, small thing, it's better if you can send the message to everyone in the group, because that way, if we miss something, others can also see the other lecturers and they can answer, because most of these are direct messages to me. And I think the person who asked about the software engineering concern was answered. Will these courses aid the undergraduate studying mechatronics? Well, it can. The same logic, right? The same thing that I said about software engineering. I took that as an example because that's the most common one. But if you're doing something like mechatronics, I'm pretty sure you've done at least a bit of Arduino programming. So it's C, C++. With that understanding, you can take up this domain. And yeah, that's definitely a career path that you can take. And the minor specialization argument comes there as well, where you can do that mechatronics specialization, that will be your degree. But then you have this specialization, the minor specialization. So therefore, with that, this can be your career path. Would it still work out even if you are a network engineer? Well, again, same thing. Software engineering, mechatronics, network. If you know a programming language, then we can build on top of it. If I need to complete all 4 courses, how much does it cost for undergraduates? I'll get to that when we come to the payment discussion in a few minutes. If someone covered above content in their degree programs, but still struggling to involve to the chip industry, still in embedded systems R&D, would like to know your advice. Okay, I'm not very sure about what your situation is, but a general piece of advice, I think it was very clear from the talk delivered by Abba. One thing is you need to show that, okay, if I wear the recruiter hat and if I get a CV from someone, one thing I look at, what are the skills, right? You list some skills on your skills section. What is that? And what are the educational programs that you have followed? It can be online, can be on Coursera, Udemy, wherever it can be these courses. What have you done? And it can even be your degree program, right? Then projects. Okay, sorry, I got a message from Zoom saying the session will expire. Okay, yeah, we have 1 hour. I don't think we'll need 1 hour. So we said 12, we are 20 minutes past, but we have to answer the questions. So we'll keep moving forward. If any of you have any other commitments, feel free to drop, but we'll have this recording available online. Okay, coming back to the question, I was talking about with the perspective of a recruiter. We look at education, we look at projects, and then, we look at education, look at skills, and the other main thing is projects. What have you done? So Abba, in his talk, he showed you like the image downsampler and then the traffic light controller and the rest of the things that he did in his internship and PhD. When you involve in one of those, something like that, one, you get visibility. The complexity of the project gives you kind of a credibility to say that, okay, I know these things. That goes a long way. And in the meantime, you connect with people in that industry because mostly it's a group project and you will have some supervisors. The supervisor will have connections. So the logic of, like I know a person who knows a person, that goes a long way. So when you involve with that community, people get visibility to your work. So that's why we wanted Abba to talk through his story of how he went from like you just like you and me as a school student to what he achieved. So we can gather, if you talk to say 100 people in the industry, especially people who went out from Sri Lanka, they will have a similar story. So out of the people who talk today, Achinta can share his story, I can share my story. They're very similar, right? So it's the same for you. If you're struggling right now, do some good projects, maintain a good resume, and apply for companies in this area. And once you have that background, well, yeah, and you ace the interview, that will be a starting point, and then you move forward from there. That's a general advice that I can give you. I don't know what your specific position is right now. Okay, should we pay all the courses in at one time or one by one? It is one by one. You can enroll in all the courses one after the other. Next question. I'm an electronic engineer from the Faculty of Engineering. Japura, very enthusiastic about chip design. What skills should I add to getting job in this field or getting into higher studies? Well, the skills that you need, that is what we are teaching you. Just to give you an overview, logic design, mainly that's the foundational course. Hardware languages like System Verilog, knowledge on computer architecture. So this is what we will provide you through this course. So to answer your question, those are the skills. In detail, we showed you the topics that we are covering in this course. Similar things will be done for the future courses, for the System Verilog one and also the processor design one. Next question, are all the 4 courses fully online? Yes, they are fully online. So even for the Synopsys tools, those who took the 2023 course, you know this, we gave access to even remote computers where you can log in through your computer to another remote computer, and then you can use those tools. Yes, it will be fully online. There was one lab session that we did where you got to play with FPGAs because, we cannot really do an FPGA deployment, well, you can do the design and verification online. Yes, you can have any Xilinx tools or Synopsys tools and get it done. But if you want to, like, touch and feel an FPGA board, for that, we had lab sessions. So that will happen for the advanced courses, but for this one, it's completely online. Okay, that's the end of the questions, at least the way the questions I got. I'll pause here. Did any of the other lecturers receive any direct messages? We can answer them. Okay, if you did, then we'll cover them. I'll move forward for now. Right. So here are a few things that you need to do. The next session. Well, I think, sorry, this is a mistake on the slide. We should call it day 1 if we call this one day 0, but you get the point. The next session will happen on 28th September. That gives you 2 weeks approximately. So we'll have this recording online on the web page, and then you can refer to it. You can send it to people who did not come today. You can spread the news, completely fine. And even if there is someone who did not register, so we had a registration deadline that ended Friday. If you did not register, the reason why we had the registration Google form is because then we know we need to send you an email, give you the Zoom link. That is the purpose of the registration form for this session, right? The one that we're having right now. But the next step will be where you make the payment and enroll in the course. So registration and enrollment are 2 different things. Registration is free of charge. We keep you informed about the session number, this one, let's call it 0. And then from the next session onwards, you need to complete the payment and enroll in the course to continue. Okay, so how do you do that? First step, you complete the payment by 25th September. That's the deadline for you. And yeah, this we covered. Let me give you a bit more details about the payment schedule, because people tend to make mistakes. Okay, this we are covering later. Okay, so here are the payment details. This is not available on the website yet, but we'll make it available together with the recording. But we'll give a brief overview right now. So this is the deadline. What you have to do is fill this Google form. Right. So yeah, another Google form. Sorry, we use a lot of Google forms, and this is one of them. This is our enrollment form. For you to fill this form, you will have to complete the payment. You have 3 options. One is to do a bank deposit. The details are here. University of Moratuwa bank account details. Or else you can do an online transfer. That's option number 2. Sorry, this should remove the bank branch because Kotobed, the branch is mentioned here. And the most important thing, whether it's cash or online transfer, is the reference. Okay. So you must mention your national ID card. If you are a foreign student, not from Sri Lanka, then your passport number. Okay, that's a must. Otherwise, we have no idea who paid. And we have had this instance where you sometimes use tellers, like automated machines, to do the cash deposit. In those automated machines, you have no way of entering a reference number. So therefore, we get a transfer and we don't know who make the payment. That we cannot accept. Okay. So please make sure that you do a deposit with the option of having that unique reference number. And that reference number is your national ID card or the passport number. Okay. Option number 3, that is where you go to the LMS and you enroll there by paying using a credit card. So we have, I'm sure you are familiar with Pay Here. We have the Pay Here portal integrated. Through that, you can make the payment using credit card or any other option that Pay Here allows you to do. Once we share this document, you will see how to enroll. There's a YouTube video that we created as a guide. You can follow them and take the course. So the LMS is not ready yet. we'll be making them ready and we'll send an email out to you with details on how to. So basically, these are the details I'm showing to you right now. So follow those instructions and complete. Okay, now the other thing is whether you choose option 1, 2, or 3, whatever that is, you need to fill the enrollment form. Okay, so it's simply making the payment, you taking a copy of your receipt and uploading that receipt through the enrollment form. That's what you need to do. Okay, so here's the enrollment form. Let's go into view only mode. Basic details, right? Name, email, phone number, WhatsApp, name as it should appear in the certificate, whether you are sponsored by your company or not, NIC, passport, which option you chose, which category you come from, whether you are undergrad or the other category. Yeah, so this is a mistake. This actually should be confirmation of student. This time, because it's the rate is very low. We have an MOU with IEEE, but there's no separate rate for IEEE because the rate is already quite less. Payment slips. This is the structure, what I just told you. Attach it, read the terms and conditions, type your name as your signature and submit. Okay, pretty straightforward. And this terms and conditions document will also be shared with you. Okay, right. I hope that's clear. We are still editing these, so this has to go away. Here are the amounts. The payment amount is 10,000 for Sri Lankan residents, and for non-Sri Lankan residents, it's $75. For current Sri Lankan undergraduates, you have a discount of 50%, which means you pay 5,000. So if you go to a barista, that's like 5 coffees. So you can measure them in number of kottu that you can have as well, whatever you prefer. But the point being, it's a very low amount. We had a problem actually because of the low amount. We started, Abba would speak to this. We started advertising this on Reddit. Hope you know it's a social media platform. And Reddit is mainly not Sri Lankans from outside. And they thought that when we charge like a very small amount, it's a scam. They were saying that, how can you, this happened to our previous course for the System Verilog one. How can you give a System Verilog course for like less than $100? That was the question. And people were skeptical that it's just uh, a money scamming kind of a thing where we collect $100 from everyone and then nothing happens. But yeah, so in typical terms, it's quite less, but we hope you get the best out of it. The reason why we price it at that point is because we don't want the price point to be a barrier to entry for people. That's why it's quite low. And there was one question about how much the entire series of courses will cost. So if you go for the non-discounted rate of 10,000, and then you have 3 other courses, and you consider the rate of those other courses without the discounted rate, it will cost you less than 1 lakh, like 100,000 rupees for Sri Lankan residents. Because that's the total for all the courses, right? The 4 courses that we showed you, right? So typically you can assume that each course is less than 25,000, around that figure. So 10,000 into 3 into 25,000, around that figure will be less than 100,000. Okay, so that's the answer to the question that came in the chat before. But as I said, there are discounts available for undergrads and for IEEE as well as we move forward. So you can make the best out of that as well. So which will drive the cost down even lower. Okay. Right. So that's about payment details. And I see a few other questions in Zoom right now. But before I answer those questions, I'm tired of speaking. So I want you to give some answers. We'll give some questions on Mentimeter and we'll come back to the rest of the questions. Right. I hope we waited long enough for you to join. Here is the next question. Okay, so most of you got it right. The question was, what is the basic building block of digital circuits? That is, in fact, logic gates. So we gave that answer even within our conversation today. So not surprised that almost all of you got the right answer. We'll complete the rest of the questions in one stretch. So here goes question number 6. Okay, similar story. Almost everyone got it right. Which of the following is not a logic gate? So, well, don't be confused. Not is a name of a logic gate, but the question is which of the following is not a logic gate? Okay, so, two different things. But yeah, you got the point. Add is not a logic gate. Everything else you will come across in our conversation, and, or, and not. Next question. Which number system is commonly used in digital systems? Well, it's binary. So you'll get to be familiar with that quite a bit. The people who said hex, we do that, and even octal is there at some points. But given that you had to choose only one answer, the most correct one is binary, because that's the most commonly, so that being the keyword here, commonly used in digital systems. Let's look at the leaderboard before we go to the final few questions. Okay, very close competition. Right, we'll cover the last 3 questions and we'll come back to the final remarks. Question 8. So these 3 questions are to see whether you were paying attention, nothing else. It's nothing to do with technical questions. So we started with some general knowledge about companies and all that. We went into a few questions about digital design, very basic ones. And the last 3 questions are about course logistics. See, even then you got them wrong. It's 25th September. So that's the payment deadline. Okay. The next 2 questions are similar, by the way. So let's see whether you've been paying attention. The certificate you are getting by which institute? Okay, since most of you have given the answer, it's from the University of Moratuwa. I hope you can't change the answer now. Can you? I should dig deeper into Mentimeter and stop speaking until the timer goes down. Anyway, yeah, it's from Moratuwa. Well, ENTC is a department within the university, but the certificate will be issued by the larger institute or parent institute. It will not be from Synopsys. Yes, it's one of our partners for the course series, but it will be from Moratuwa. Last question, again about course logistics, just to make sure you understood, because we've had the experience, even though how many times you repeat instructions on the first day, at least there is one person who makes a mistake. Here we go. Last question. Okay, even then you got it wrong. You have multiple options. One is a deposit in a bank, gave you instructions. Number two is an online transfer. Number three is credit card or anything, any other option that Payee offers you. The reason why I added the question is I wanted to emphasize again, please don't use ATM machines, since then, if you do that, we are unable to track the payment. We've said this multiple times, even in previous courses, but then there's at least one person who does that, and we have no way of verifying that it is that person, and then we have to go into a very unpleasant conversation. Okay, so please don't. It's not very difficult, right? You just fill a form with your name and details, and you add the reference number, your NIC or passport. That's it, right? So please make sure you follow those instructions. That brings us to the end of the quiz, and let's see who is the winner at the end of all this. The winner, whoever this is, please drop a personal message to me. Well, you can even send it to everyone with your email address, and we will reach you. That's Lasantha, the penguin. So the penguin Lasantha, you will have to drop a message and we'll provide you with the gift. Okay, so you can drop that in the Zoom chat and we'll make a record of it. If there's more than one person claiming to be Lasantha, that's a problem, by the way. So yeah, okay, I got a message from Lasantha. Right, let's go back to the last few slides. So this is what you need to do moving forward. This we mentioned several times, course completion requirement to obtain the certificate. You must complete the evaluation criteria, and attendance will not be taken, but we encourage you to come. If you don't come, you can't ask questions, then the interaction is less. So it's more like passive learning rather than actively taking part in a conversation. So we recommend you to come for the lectures. Course materials made available through LMS, and course communication mainly through the WhatsApp group, and emails can be there as well. But please make sure that you refer to the WhatsApp group messages typically on Friday, so that you know what's happening over the weekend. More details are here, the web page. So this is the same web page that you went to register. Now the page will change with this recording and also the instructions within the next few days. So we have a bit of a challenge because it's a weekend and many people are taking holidays over the long weekend. So might take a couple of days, but once that is there, we will send an email out to you so that you can get to know what the next steps are and follow them. So finally, we emphasized this several times, many different career opportunities, mainly in the design space of things. We want the courses to be real world applications, to have real world applications, industry ready training, and you will get expert support from the panel of lecturers. And finally, we expect you to go here, stepping into a niche, high demand field. So if you have any further questions, you can send in the chat. Let me now spend some more time answering the questions that came in through Zoom so far. Yeah, if I'm at the correct location. The most recent question that we did not answer, sorry, the question that came in that we did not answer is, will we have the opportunity to do group projects? Well, in course number 1, you don't, because it's a foundational one. We expect everyone to do things on their own. And then later on in the future courses, group projects can be there. So once we decide exactly what those projects are, then we will let you know. Yes, it is possible. Completed my degree in physics, still not graduated, enrolled as a demonstrator. Am I eligible for the undergraduate category? Okay, so there are corner cases like this. Drop us an email. We've given you contact information. There's a WhatsApp number as well as emails. So drop an email or WhatsApp. Give us evidence about where you are right now, and then we'll handle those corner cases. Question is, a student at ENTC, is it still worth getting this course? Because I will anyway be learning this stuff in your main degree. Well, yes, you will be learning them. As I said, the curriculum, the one that you're presenting through this course, it's unique to this course. So this flow will be there only in this course, but yes, aspects of it will be covered to you through the NTC curriculum. So depending on how well you gather or grasp content, it's completely up to you to make a decision on whether you want to enroll in this one or not. It's your learning pattern. So yeah, concept-wise, you will get this from ENTC. Yes. Will I face problems when apply for my degree if I register for this course? Well, yeah, Jazuli has answered. Yeah, you will not have an issue. It's another line in your resume, or it's a value addition for you. Do you mean that it's better taking this course? Because even in the university, I did labs related to FPGA without much understanding, and I really like to have thorough understanding. Well, yeah, I mean, if you would like to get better understanding on this area, you are at the right place. You can take this course. I'm a bit confused why it can be a problem for your degree. Maybe if you can elaborate, we can answer that better. But as I mentioned earlier, think of it as a specialization that you do in addition to your main degree. That's a value addition for you. So, how to join the WhatsApp group? We will be adding you to the WhatsApp group because you already shared your numbers when you send the registration details. If you, for whatever reason, you did not fill the registration form, in the instruction emails, we will add a link to join. Hold on. Okay, you're referring to the, okay, sorry, please forget about what I said. This WhatsApp group, the one that you will be added to, that will be taken from the enrollment form that you did not fill yet. Okay, so in the enrollment form, there's a field for you to put your WhatsApp number, and everybody who fill that form, we will create the group and we'll add you. That group will not have an invitation link because only the people who made the payment will come into that group. Therefore, a link will not be circulated. The administrators will curate that group, will add you one by one once you fill the enrollment form. Sorry for the confusion. I had something else in mind. Are there any startups for this area aside from corporate companies? Yes, there are startups. We know quite a few working in this area, and there are startups providing talent or workforce extension kind of services to companies outside of Sri Lanka as well. So it's not uncommon for you to be here and then work for a company somewhere else. Yes, there are companies. Question, I studied course 1 basic in my engineering curriculum. Is this compulsory to enroll course 1? Well, if you want to skip the foundational course and take course number 2, it's completely up to you, but we will not be repeating what we covered in the foundational course. So we showed you the topics that we're going to cover. If your degree program or whatever other course you took already covers them, you can skip this one and come to the second one. But the only thing that we will not do is to cover, because we have a series of courses. And another reason why we have it as a series is we don't want to spend time in course number 2, covering course number 1, because that is unfair for the students who did course number 1. We can have a refresher, we can do a recap, we can connect back to the first course, but you can't expect us to teach you the core content from course 1 again. Because the reason why I said it's unfair is because those who are paying for course number 2, they don't want to pay to learn what they already learned, right? So therefore, we'll have that clear demarcation. If you're getting that knowledge from somewhere else, perfectly fine. You can directly come to course number 2, but we'll not be repeating course number 1. Is this course like 4 modules stretching to several semesters in a normal degree? Yes, that is exactly what it is. So you can think of it as the series of courses. If you're enrolled in a degree, you do a beginner's level course in, let's say, semester 2. You do a more advanced one in semester 3, then semester 4, and so on. But in this case, the timelines are shorter because a typical semester is about 4 months. But in this case, it's about 2 to 3 months, and with gaps in the middle, gaps in between. So yeah, that's a accurate interpretation of it within a short time period. Question about master's programs in ENTC. So we'll not go into detail because this session is not to talk about master's program. The short answer to your question, which is asking, are there master's programs in ENTC, which is covering FPG and digital design? Yes, there are master's programs. To give you a name, we have a PG dip in electronics and automation, master's in electronics and automation, and master of the science of engineering in electronics and automation. What I said, if all those 3 things sounded similar, it is because the words sound similar, but these are different qualification levels. One is a PG dip, which is a different SLQF qualification level. Master in is another, that's SLQF 9, and MSc, which is the Master of the Science of Engineering, that is SLQF 10. So you have different degree programs, different credit amounts. So you can check out the website. Okay, this might sound a bit silly. Well, that's not my comment, by the way. That's the question coming in Zoom. We'll not take the name of the person because it's a direct message for me. How it will be like the competition when someone from SE or CS versus EE background apply for this sort of job? Well, what I can tell you is, let me tell you a story. Abba told you about the friend who who was in the lab and went to NVIDIA. I had a friend in my lab who was a civil engineer, the first degree. His bachelor's was a civil engineer. He did the PhD in computer science and he got a job offer at Google. Well, I hope I answered the question through that. If I tell you the same thing in different words, your initial background, the first degree is your foundation, right? And if you are thinking that that particular degree will allow you to survive in the industry for, let's say, 40 years, that is not going to happen. So you'll have to continuously learn and relearn and unlearn things. So the first background is your foundation. You get the ability to learn through the first degree. Because 40 years from now, forget about 40 years from now. Imagine 2020. Did any of you predict that Gen AI will be where it is? Well, there's not even a deep learning architecture that came in 2010. So what would happen in 40 years from now, nobody knows. Therefore, the initial background is your stepping stone. Once you enhance the skills, it doesn't really matter. If you want to go into this area, whether you come from SE or EE, you do this well, you have the skills and you can prove that you have the skills in a job interview. That's what matters. If you think that you are lacking in a certain area, of course, you can cover that. And for the purpose of this specialization on chip design, whatever you need to cover, that is our job to deliver that to you. Okay, I hope it's clear. How can we apply for course number 2? Are there any Google form? It's very similar to what you did right now. When we announce the second course, System Verilog 1, we will set up a registration form. You will register free of charge. We'll have a live session and we'll tell you what we cover. And then again, you will have time to pay and enroll. Same process. Okay, done with questions. Do we have any other things from other lecturers? Did you get any direct messages, anyone? Okay, guys, I'll take that as a no. No comments from anyone. So I think we can wrap up. We took more time, well, because we had a lot of questions coming in. So we had about, I think, if I'm not mistaken, about 120 taking part in the live session today. In the registration form, we had close to 350. Those are good numbers. So it's great to see all of you here today. And with the knowledge or the information that you got from today's session, we hope you take the decision, and then we hope to see most of you from day 2 onwards. So thank you for joining us on a long weekend on a Sunday. We thought of shifting this session to the next week, but we decided against it because we said from the very beginning that we'll have it on this weekend. So that's why we did not want to change anything. Thanks. We hope to see you from day 2 onwards, and have a good rest of your long weekend.